So how can we find out these quantum numbers if we are given an n, or the energy level? So an easy way is L equals n minus 1. ML is just, it's a range from positive L to negative L. That's the range of it. So for example, if L is equal to 1, then ML is plus 1, 0, minus 1. It will include 0. If L is 2, then we would have plus 2 and minus 2. But if L is 0, well, 0 can't be positive or negative, and so it'll just be 0. The MS, it just depends on how many electrons you have, and each electron would have a plus 1/2 or a minus 1/2. So now we know the 4 quantum numbers. Let's put it to practice. Let's begin with the first energy level, so that means n will equal to 1. L, the angular momentum quantum number, shows the shapes we are dealing with, or the sub-levels. And so, L, how to find this out? We use n minus 1, which 1 minus 1 is equal to 0. So that means L is 0. ML, the magnetic quantum number, shows how many orbitals we are dealing with the shapes that we know of the orbital. And so, it is just the range of positive L to negative L. So positive 0 to negative 0 is just 0. That means we're dealing with only one orbital. And I just want to note that each orbital can only hold 2 electrons. Alright, so being able to hold only 2 electrons means that there are only 2 electrons to spin. They have to spin in different directions, so one will spin in plus 1/2 and one will spin in minus 1/2. So we know in the first energy level, how many electrons are there? Well, we know there's only one orbital, and if we fill it up, there's only 2 electrons. So only 2 electrons. Let's move on to the second energy level. Alright, so n equals 2. And we want to find out L, which is n minus 1. And 2 minus 1 is 1. So what does this mean? It's not only 1 that we're dealing with. We're also dealing with 0. So if we have a number higher than 0, we're dealing with all the numbers in between 0 and whatever number we got. So we have 0 and 1. Now, do you remember what these numbers correspond to? What letters? 0 corresponds to S, and 1 corresponds to P. So we are dealing with 2 different types of orbital shapes. Now, let's find out how many orbitals we are dealing with. So for 0, let's find out the magnetic quantum number. So positive L to negative L for 0 only. Well, it's just 0. And that means there's how many electrons in this? There's 2 electrons. And you know they'll be spinning in different ways. So there's 2 electrons there. How about for 1? 1, which is the P shape, how many orbitals do we have that are in the P shape? So it's positive L to negative L. This dotted line is just to separate 0 and 1. So we have positive L to negative L. We're dealing with 3 orbitals, or 3 different spatial orientations. Just as I said earlier, P can be oriented like this, or like this. And so this means there are 2 electrons in each orbital. So there's 2 here, 2 here, 2 here. And we know they are all spinning differently in each orbital. So this one has plus 1/2, minus 1/2. This one has plus 1/2, minus 1/2. This is plus 1/2 and minus 1/2. That just shows that there are 2 electrons in each orbital. And so, how many electrons are in total for the second energy level? Well, this might be confusing to look at, the spin, because we don't necessarily need the spin to count the amount of electrons there are. Just remember that in each orbital there are 2 electrons. So we have 4 orbitals and 2 electrons each, which means that we're dealing with 8 electrons in total.